Artificial intelligence evaluating models. Overview. Learning objectives. By the end of this topic, you will be able to understand the purpose and steps involved in AI model evaluation, perform train test, splits, and explain why they are necessary, interpret a confusion matrix and identify true positive, true negative, false positive, false negative, calculate and explain accuracy, error rate, precision, recall, and F1 score. Choose suitable evaluation metrics based on real-life AI applications. Identify different types of classification problems. Analyze the impact of poor evaluation and how it can lead to unfair or harmful AI decisions. Recognize and address ethical issues such as bias, lack of transparency, and privacy risks in AI. Importance of model evaluation. After creating and training an AI model, the next important step is to check how well it works. This is called model evaluation. Evaluating the model helps fix these problems before using it. What is model evaluation? Once the model learns from the training data, it is tested with a new set of data called the testing data. The testing data is completely different and new for the model. This helps check if the model can make correct predictions on unseen data. Usually, the data is split into two parts. Training data used for teaching the model. Testing data used to check the model's accuracy. The exact split can change depending on the problem. Steps in model evaluation. The steps involved in the model evaluation are: compare testing results with training results. First, the model's performance on testing data is checked against how it performed on training data. If the model performs well on both, it means it has learned properly. Compare with real-world data. Then, the testing results are compared with actual results from the real world to see if the model's predictions are accurate. Deploying the model. If the model passes these checks, it is deployed in the real world. Monitoring the model. After deployment, the model's performance is monitored over time to make sure it keeps working well. Example: predicting student exam results. Imagine you created an AI model that predicts whether a student will pass or fail an exam based on their study hours, attendance, and previous scores. You train your model using data from 700 students. Then you test it on data from 300 new students. After testing, you check if the predictions match the actual results of these students. If the model's predictions are mostly correct, you start using this model in schools. Later, teachers keep checking the model's predictions regularly to make sure it still works well. Splitting the training set data for evaluation. Train test split. When we build an AI model, we divide our data into two parts. Training data, used to teach the AI model by showing it examples. Testing data, used to test how well it can predict on new, unseen data. The training data helps the model learn while the test data checks how well it learned. This is called a train-test split. Usually, a common split is 80% training and 20% testing. How to perform train-test split? Divide the data. Split your full dataset into two parts, training and testing. Usually, this is done randomly to keep it fair. Choose the ratio. Common splits are 80% training, 20% testing. 70% training, 30% testing. 90% training, 10% testing. Types of splits. Random split, data is divided randomly. Stratified split ensures each class has a similar percentage in both training and testing sets, useful when classes are not balanced. Real-time example, email spam detection. Imagine you have 1000 emails labeled as spam or not spam. You use 700 emails to train your model to recognize spam. The remaining 300 emails are used to test if the model can correctly identify spam emails it has never seen before. This way, you check if your spam detector works well on new emails. Accuracy and error. Accuracy tells us how many predictions made by a model are correct out of all the predictions it made. Understanding correct predictions. True positive, model correctly predicts a positive case. True negative, model correctly predicts a negative case. False positive, model predicts a positive case but it's wrong. False negative, model predicts a negative case, but it's wrong. So, accuracy is calculated as accuracy is equal to true positive plus true negative divided by true positive plus true negative, false positive plus false negative by 100. Why accuracy can be misleading? Imagine a disease prediction where 95 out of 100 people are healthy. If a model always says healthy, it will have 95% accuracy, but will fail to identify the 5 sick people. Error rate. Error rate shows how often the model is wrong. A high error rate means the model is making many mistakes. Formula. Error rate is equal to 1 minus accuracy. Or error rate is equal to false positive plus false negative divide by true positive plus true negative plus false positive plus false negative. Together, they help us understand how good the model is. Example. If your AI model predicts the correct result 8 out of 10 times, the accuracy is 80% and the error is 20%. Higher accuracy and lower error mean a better model. Evaluation metrics for classification. What is classification? Classification is when an AI model learns from labeled data and classifies new data into groups or categories. It answers questions like: is this a spam email or not? Is this person likely to buy a product, or is this image showing a cat or a dog? Classification models learn from labeled data. Types of classification. Binary classification predicts one of two options. Example, is an email spam or not? Multiclass classification predicts one out of many categories. Example, is an animal a cat, dog, or bird? Multilabel classification. Predicts more than one category for one input. Example, a news article can be about both sports and politics. Applications of classification in artificial intelligence. Spam detection. AI models are used to classify emails as spam or not spam. Example, your email inbox filters out unwanted promotional emails automatically. Medical diagnosis. AI helps in predicting whether a person has a disease based on their symptoms. Example, detecting COVID-19 from symptoms like fever, cough, and breathlessness. Sentiment analysis. AI analyzes text and classifies it as positive, negative, or neutral. Example, checking if a review on a shopping website is happy or unhappy. Fraud detection. AI detects if a financial transaction is fraudulent or genuine. Example, banks use AI to alert customers about suspicious activity in their accounts. Image recognition. AI identifies objects or people in images. Example, social media apps tagging your friends automatically in uploaded photos. What are evaluation metrics? Evaluation metrics help us check how well a classification model is performing. We do this by comparing the model's predictions to what actually happened in real life. Understanding the scenario. Scenario means the real situation where the model is used. The model receives data regularly or in real time. Regular interval scenarios. These happen less often and are usually less urgent. Examples, monitoring pollution weekly, tracking student progress, or fitness checks for athletes. Real-time scenarios. These require immediate action because they can be life-threatening or critical. Examples, predicting floods, monitoring heart patients, or detecting fraud during online banking. Comparing prediction and reality. When the model makes a prediction, it can either be correct or wrong. The prediction is usually in the form of yes or no, true or false, or positive or negative. 4 possible outcomes of a prediction. Confusion matrix. A confusion matrix is a table that shows how many correct and incorrect predictions a model has made. It has 4 values: true positive, false positive, true negative, false negative. Example, disease prediction. True positive. If the model says yes, and the patient actually has the disease. True negative. If the model says no, and the patient is healthy. False positive. If the model says yes, but the patient is healthy, false positive. False negative. If the model says no, but the patient actually has the disease. Classification metrics. In AI, especially in classification problems, it's important to know how well the model is performing. For this, we use evaluation metrics like accuracy, precision, recall, and F1 score. Each of these helps us understand different aspects of a model's performance. Accuracy tells us how many predictions were correct out of the total. But in real-life situations, where some classes are more important, accuracy alone isn't enough. Formula. Accuracy is equal to true positive plus true negative divided by true positive plus true negative plus false positive plus false negative. Use case, effective when classes are balanced. Precision shows how many of the predicted positive cases were actually correct. It's useful when the cost of a false positive is high. Formula: precision is equal to true positive or true positive plus false positive. Use case: useful when false positives are costly. Recall tells us how many of the actual positive cases we were able to identify. It matters in cases where missing a positive case can be dangerous. Formula: recall is equal to true positive or true positive plus false negative. Use case: important when false negatives are costly. F1 score combines both precision and recall. It's useful when we need a balance between them, especially when the classes are imbalanced. Imagine you build an AI model to detect whether an email is spam or not. Accuracy shows how many emails were classified correctly. Precision shows how many of the emails marked as spam were really spam. Recall shows how many actual spam emails the AI caught. F1 score balances precision and recall, especially helpful if you don't want to miss spam, but also don't want to wrongly mark normal emails as spam. Ethical concerns around model evaluation. AI models are used in real-world applications like job hiring, medical diagnosis, loan approvals, traffic control, weather forecasting, and more. But if AI is not carefully evaluated, it can cause ethical problems such as unfair treatment, privacy violation, or unclear decisions. Let's explore the key ethical concerns in AI model evaluation, each with real-time examples for better understanding. Bias in AI models. Bias in AI occurs when the model gives unfair advantages or disadvantages to certain people or groups because of the data it was trained on. Example: AI in hiring platforms. Amazon once developed an AI recruitment tool to scan job applications. The model was trained mostly on resumes submitted by men over a 10-year period. As a result, it favored male candidates and discriminated against women, especially those who used the word women's. Ethical issue. This is gender bias and is unethical. The model wasn't fair to women candidates. Solution. Check model performance for all groups like gender, caste, economic status. Use balanced and inclusive training data. Transparency and explainability. Some AI models are so complex that even developers can't explain why they made a certain decision. This is known as a black box model. Example: AI in exam scoring. In 2020, the UK government used an AI model to grade students since exams were cancelled. The system downgraded many students, especially from low-income schools, without clear explanation. Public backlash forced the government to cancel the AI-based results. Ethical issue. The AI decision was non-transparent, and students didn't know why they were graded unfairly. Solution. Use explainable AI models. Make sure users can understand how decisions are made. Provide human oversight for sensitive decisions. Accuracy versus fairness. A model might be highly accurate overall, but it may still give unfair results to certain groups. Example: loan approval AI. Some AI models used by banks or credit agencies have been shown to approve more loans for people from urban areas than for equally qualified rural applicants. The model is accurate by numbers, but it discriminates against people from rural backgrounds. Ethical issue. Accuracy is high overall, but individual fairness is missing. Some groups suffer unfairly. Solution: evaluate using precision, recall, F1 score to find hidden problems. Check fairness for each community or group the model serves. Privacy concerns. AI often uses personal information for predictions. If too much private data is collected or misused, it's a privacy violation. Example: social media targeted ads. Cambridge Analytica used Facebook users' personal data including likes, interests, and friends without consent to show them political ads and influence voting behavior in elections. Ethical issue. People's private data was misused to manipulate opinions. This caused huge criticism. Solution: collect only necessary data. Follow privacy laws like GDPR or India's Digital Personal Data Protection Act. Use data anonymization and secure storage.